Hello everyone. In this session, we are clearly going to distinguish between the traditional way of creating a chain by using this particular class called LLMChain, which is deprecated now, and also by using this more modern way of creating the chain, which is LCL, which stands for LangChain Expression Language. If you remember, we basically have created a chain by using these multiple components like C1, C2, and C3 that I have provided here for namesake. Each of them is separated by a pipe operator or an OR operator here, right? So this pipe operator is what is chaining all of these components together. Okay. Each of these components can be associated with something called as a runnable object. By the end of this particular session, we'll clearly understand what a runnable object is in LangChain. Okay. So this is a more modern way of creating a chain in LangChain, and this particular class is deprecated in the most recent versions of LangChain, and it might not be available in the future versions as well. Okay, and hence we'll resort to LCL style of creating a chain now. Here, if you can observe the code, we basically have created three different components, one of which is a prompt, the other one is the object of this chat model chat OpenAI, and also the output parser. So we are going to leverage all of these three different components and then look at creating a chain using the traditional way or traditional approach, which is by using this class called LLMChain. So within parentheses, we are supposed to provide all of these particular parameters like the prompt. The prompt is going to be the prompt itself that we have defined in the previous step. LLM is going to be the chat model object, and the output parser is going to be string output parser that we have defined in the previous step. So this I'm calling it as LLMChain. LLMChain dot run, and within parentheses I'm going to provide the variable name here. The variable name here is going to be topic. So what exactly is the topic that we would want a response from the LLM? Let me provide generative AI as a topic and assign this to something called response, and later look at printing the response. So we now have actually included three different components or chain three different components together, one of which is a prompt followed by the chat model followed by the output parser. So the output parser is going to extract the response from LLM and provide the response in a more formatted fashion like what you're currently observing. Okay. So we got the response back from the large language model, that is by invoking this particular chain. So whatever topic or the variable value that you are trying to provide here is being considered or injected into the prompt, and whatever output from the prompt that we are having is fed as an input to your chat model. The output from the chat model is later fed as an input to your output parser. That's the whole process that has been done. And we clearly know that LLM chain, which is a class here, is now deprecated, and it's not encouraged to use that anymore. We'll rather use this LCL way of creating a chain now. So how do we actually go about creating a chain by using this new approach? We simply make use of all of these different components that we already have created. That is a prompt, the chat model object, as well as the output parser separated by this particular pipe operator. And I'm calling this as chain now. And that's all. Chain.invoke. And within parentheses, let me provide a dictionary of key value pairs. The key here being the variable name. Variable name is topic, which is being used within the prompt here. So within this particular prompt, we are using this variable called topic. So now let's actually provide what our topic could be. Our topic could be generative AI like we have provided in the previous step. So this again is assigned to a response, which I'm calling as response one, since we already have response. Since we already have stored our earlier result in response, now I'm storing it in a different variable altogether. Let me print the output as well. So now we clearly understand that whatever chain that we have created by using this new approach also works well. Okay. The output of prompt is now being sent as an input to your LLM, and the output of LLM, which is a chat model object, is now being fed as an input to your subsequent component, which is your output parser. So that's the whole functionality of this pipe operator. So what actually works under the hood of this particular pipe operator is a runnable. So runnable is a key concept that we'll have to learn And we'll also try to understand how we basically wrap any given function as a runnable object and use them in chaining together like what you're currently observing. So each of these, the prompt object, the chat model object, and the output parser object, all of these are nothing but runnable objects. All these components are runnable objects. Let's actually try to write a custom runnable class and try to understand how runnable classes like RunnableLambda within LangChain works internally. Okay, this is a custom class and we are not actually copied this code from any of the LangChain documentation that's available. And if you are closely observing this, we basically have this method called _r, which is implying this particular pipe operator or OR operator. Okay, first let's look at writing a couple of functions for us to understand about this particular class a little better. Right, so let's define a new function called double. Let me define a new parameter as well while creating it. So I'm just trying to double this particular number x that is being received as a parameter, returning x square. That's all. Let me also write a new function called increment, which also accepts one parameter called x here again. So we are going to return x plus 1. The simple mathematical operations are now wrapped as functions called as double and increment. Now, whatever class that I have defined here, which is called as runnable, I'm just passing in one of these functions as an argument. So this now is going to be my func. So double is a function, user-defined function, which is now assigned to this particular function called func. Right? While you instantiate this particular class, you basically are tying this function to the object itself. Right? So this is being invoked first. So double is being invoked first with whatever values that you are passing while you invoke this runnable object. So you are later wrapping this within another outer function called as other. That's the whole purpose of it. So you are just sending the output of double function as an input to your subsequent function. So that's what this pipe operator is doing, right? So whatever output that you get from prompt is being sent as an input to your subsequent component, which is chat model. So that's what you're doing. So the output from this function is being sent as an input to your subsequent one. That's what we are exactly implementing here. And this chain function returns exactly the same. And hence I have wrapped this again as a function within parentheses and just returning the runnable object here. Let's consider these two different functions, double and increment, and create runnable objects by using this runnable class here. So let me call this as double runnable, and let's also call this as increment runnable. The next object that we are going to create is going to be increment runnable. So where we are going to pass this particular function called increment. So now we have basically created a couple of runnable objects. We have both of these runnable objects now defined, and we create a chain by using these two runnable objects, one of which is double runnable, the other one is going to be increment runnable. Calling this as chain. I'm calling this as chain, and I'm invoking this particular chain by passing in a specific value within the parentheses. So the output of double runnable, which is going to be 25, is now being fed as an input to your subsequent runnable object. That is an increment of 1 to the result of the prior component. So the result is going to be 26. This is exactly what we are implementing as part of the LCEL way of creating a chain here. So the output of prompt is being sent as an input to your right hand side component, which is a chat model. The response from your chat model is again sent to your output parser, which is going to parse the response and provide it in a more standardized manner. So this is what we have implemented now, right? So this particular or _r operator does imply operator overloading. So if you are familiar with operator overloading that you must have learned in object-oriented programming basics, you clearly understand what we are doing here. So the same functionality that we have obtained here in this particular statement can also be obtained by making use of that particular _r method, right? It's nothing but the same. The result is going to be the same. So we basically have done operator overloading. So using this pipe operator is exactly same as that of using this particular method called OR, right? Now let's look at using the runnable class that we can import from LangChain core library. LangChain core.runnables import RunnableLambda. So RunnableLambda is the class that we are going to leverage for creating our runnable object. We are going to make use of the same functions, double and increment. So double and increment are the two functions that we already have created. And now this is runnable double and this is runnable increment, okay, which are created using this RunnableLambda class that is directly imported from LangChain library. So earlier we have not imported any runnable class from any of the given libraries, but rather we have written our own custom code. But now we are making use of RunnableLambda that's imported from LangChain core library. So we now have these two different runnable objects. We simply can chain them together by using this pipe operator. And now you can make use of chain.invoke and provide a specific value so as to observe what the result could be. The result is pretty straightforward, isn't it? For the first instance, you basically have 10 square, which is going to be 100. And this is being fed as an input to your subsequent function, which is going to be increment. This is your x now for increment. So 100 plus 1 is going to result in a value of 101. And that's what you're observing here. I hope that you have clearly understood how you basically can leverage RunnableLambda and wrap your functions as runnable objects or components, which you can later chain them by using the LangChain expression language that we have learned earlier. You simply can use this invoke method and pass in the necessary value so as to deduce your resultant output from your chain. In the next session, we are going to learn about the different classes apart from RunnableLambda. So what other classes are there? Should we learn about runnable sequence, runnable parallel, all of this? And in what cases we should use what? Is what we are clearly going to understand in one of our upcoming sessions. Thanks for watching.